Okay, class. Isang magandang araw sa inyong lahat. Okay, so welcome back. Ngayon ay discuss natin yung ating exam last time, yung quiz 2, which is rectilinear motion with constant acceleration. And congratulations nga pala doon sa mga nakaabot ng cut-off at sa nagbabasa agad ng directions. Para naman doon sa hindi nakaabot ng cut-off, good luck. Ayan, so ngayon i-discuss natin yung exam natin nung nakaraan, which is the quiz 2, rectilinear motion with constant acceleration. Para dun sa ating problem number 1, water drops from a faucet at a rate of 3 drops per second. What will be the position of the lower drop if it has attained the velocity of 4 meters per second? Second, what will be the position of the upper drop if the lower drop attained the velocity of 4 meters per second? And number 3, what will be the distance between two consecutive drops after the lower drop attains a velocity of 4 meter per second? So dito sa problem number 1, meron tayong tatlong question. For the first question, what will be the position of the lower drop if it has attained the velocity of 4 meters per second? Siyempre, balik tayo dun sa unang process natin, which is the given. So ano ba yung given natin? Dito sa number 1, meron tayong given na velocity initial, which is 0 meters per second. So bakit nagkaroon siya ng initial velocity na 0? Since class, sinabi ng problem na water drops. Pag sinabing drops, automatic yan, ang kanyang velocity initial ay 0. Second, we have the velocity final, which is 4 meters per second, given in the problem. And the acceleration, which is equal to the gravitational pull or the gravitational acceleration, equal to 9.81 meter per square second. So, anong-ano natin? The position of the lower drop. So, based on sa ating key formulas, kung makikita natin ang ating given, we have V1, we have V, we have A, and the unknown is the SL. So, since given na itong V1 and V natin, pwede natin gamitin yung formula number 2, which is V squared is equals to V1 squared plus 2AS. So, substituting all the values, V squared is equals to V1 squared plus 2AS will result to position of the lower drop is 0.815 meters. Ayan po, malinaw na malinaw, direct substitution lang po tayo. Since we're talking of the gravitational pull or the gravitational acceleration, it is always negative. So G is always negative. When it comes to distance, just neglect the negative sign. So for question number 2, what will be the position of the upper drop if the lower drop attained the velocity of 4 meters per second? Kung titignan natin class doon sa ating figure, ang unknown natin is the position of the upper drop. So what are the given? Given is V1, which is 0 meter per second, A, which is equal to 9.81 meter per square second, and the unknown, which is the SU, or the position of the upper drop. So, balik tayo dun sa figure natin. Dito sa figure natin, meron tayong dalawang situation. Wherein situation 1 is the time traveled by the upper drop if the lower drop attained 4 meter per second. So, kung na-attain daw ni lower drop yung velocity na 4 meter per second, ano daw yung magiging time ni upper drop? So, using the formula V is equals to V1 plus 80, time for the lower drop to when it reached the the velocity of 4 meter per square second is 0.408 seconds. Then, if 3 drops fall per second, time interval of each drop is 1 second over 3 drops. So, time interval of each drop is equals to 0.333 seconds. So, yung bawat drop daw ay nahuhulog siya every 0.333 seconds. Therefore, yung time ng upper drop nung simula nung nahulog siya is equals to T upper is equals to T lower drop minus T initial. Wherein the time for the upper drop when lower drop reaches 4 meters per second of velocity is equal to 0.075 seconds. So ano yung kaugnayan nun doon sa ating problem? Since hinahanap dito is what will be the position of the upper drop if the lower drop attained the velocity of 4 meters per second, madadagdagan yung given natin. So madadagdagan siya ng time para doon sa upper drop nung na-reach ni lower drop yung 4 meters per second na velocity. So using the formula, S is equals to V1 plus 1 half 80 squared. So substitute all the values will result to the position of the upper drop is equals to 0.028 meters. Ayan. Nakuha. So for question number 3, what will be the distance between two consecutive drops after the lower drop attains the velocity of 4 meter per second? So, ilan daw yung distance ng consecutive drop, ng dalawang drop na magkakasunod kung naabot na ng lower drop yung velocity na 4 meter per second? So, given, since na-solve na natin yung SL or the distance or the position of the lower drop mula doon sa labi ng faucet, which is equal to 0.815 meters, and also the position of upper drop, which is 0.028 meters. Therefore, SF is equals to SL minus SU, or position of the distance between the lower drop and the upper drop is equals to the position of lower drop minus the position of upper drop. So 0.0815 meters minus 0.028 meters. The distance between the two drops is equals to 0.787 meters. Alright? So, question po tayo doon sa number 1, problem number 1. Okay, here we go for question number 2. So, question number 2 is quite tricky. Kasi isang problem lang or isang tanong lang siya pero napakaraming hahanapin. Sabi dito, a driver traveling at 50 miles per hour sees a wall at a certain distance ahead. The driver applies the brakes immediately. We have perception time is equals to 3 seconds and begins slowing the vehicle at 6 meters per square second, decelerating. If the distance from the stopping point to the wall is 12 meters, how far was the car from the wall upon perception? So meron daw driver na nagta-travel ng 50 miles per hour, tapos bigla niyang nakita yung isang pader. Nung nakita niya yung pader, syempre, ang tendency mababangga siya. Kung ikaw nakita mo agad yung pader, automatic, yung nakita mo, mag-register doon sa utak mo, which is yun yung time ng perception. Once na na-receive na ng utak mo yung command ni mata na mababangga ka, gumana si utak at nagutos doon sa paa para mag-preno. So, yun yung problem number 2 natin. So, dito sa problem number 2, meron tayong tatlong cases or tatlong situation. Wherein, first situation is the time of perception. Second situation is yung time na kung saan nag-apply na ng brake yung driver. And the third situation na kung saan tumigil na yung sasakyan. Okay, ano nga ba ang tanong? Back to the question, how far was the car from the wall upon perception? So, gaano daw kalayo yung kotse simula nung ma-perceive niya na siya ay mababangga? Okay? For situation number 1, meron tayong given na V1 or the initial velocity of the car which is 50 miles per hour or equal to 22.36 meters per second. Acceleration is 0. Why 0? Kasi doon sa perception time niya, within 3 seconds, hindi pa siya nakapag-brake. So, maintain yung speed niya na 50 miles per hour, which is the initial speed, and also the final speed niya doon sa perception time na 50 miles per hour. So, acceleration is constant, which is equal to 0. So, hindi nag-accelerate nor nag-decelerate yung kotse doon sa perception time na 3 seconds. So, ano pa yung given natin? We have the perception time which is 3 seconds. So, ang hinahanap natin dito is gaano kalayo yung na-travel ng kotse simula yung na-perceive niya yung pader hanggang doon sa bago siya mag-apply ng brake sa kanyang sasakyan. So, for situation 1, perception time, S is equals to V1T plus 1/2 AT squared. Since acceleration ay 0, ang formula natin ay marireduce into S is equals to V1T. So, substitute all the values. S ng perception time is equals to 67.08 meters. So, within the perception time na 3 seconds, nakapag-travel pa yung sasakyan ng 67.08 meters. So, for situation number 1. Situation number 2. After applying brakes. So, ano yung given natin? The same, we have V1 is equals to 50 miles per hour or equal to 2.36 meters per second. V final. Bakit siya naging 0? 0 siya kasi sinabi ng problem na the vehicle, if the distance from the stopping point to the wall is 12 meters. Ibig sabihin, yung situation number 2 is mula nung nag-apply siya ng brake hanggang sa tumigil yung sasakyan. So, pag tumigil, ibig sabihin, 0 acceleration, 0 velocity. Kaya naging 0 yung ating final velocity. Then, acceleration which is 6 meters per square second, which is given in the problem. Then, we're looking for S2 or yung distance na tinravel niya mula nung nag-apply siya ng brake hanggang sa tumigil yung sasakyan. So, using the formula, V squared is equals to V1 squared plus 2AS. 0 squared is equals to 22.36 squared minus 2. So, negative kasi sinabi ng problem na it is decelerating. Therefore, acceleration is negative. Times 6 S. So S is equals to 41.66 meters. So simula na nag-apply ng brake yung driver hanggang sa tumigil yung sasakyan, ang total travel ng sasakyan doon sa point na yun ay 41.66 meters. Okay, situation number 3. Nung tumigil na yung sasakyan. Nung tumigil na yung sasakyan, sabi ng problem, ang distance ng sasakyan mula doon sa pader, simula nung tumigil siya ay 12 meters. So ngayon, since 12 meters, yung sa situation number 3, nung tumigil siya, ang tanong ng problem natin is, how far was the car from the wall upon perception? So, gaano daw kalayo yung kotse mula doon sa pader, simula nung na-perceive nung driver yung pader. Okay? Given distance doon sa time ng perception, which is 67.08 meters. Distance simula nung nag-apply siya ng brake hanggang sa tumigil yung sasakyan, which is 41.66 meters. Distance nung tumigil yung sasakyan hanggang doon sa pader ay 12 meters. So solution, total is equals to S1 plus S2 plus S3. So total distance nung car mula doon sa wall upon perception is equals to 120.74 meters. Ayan po. Nakuha. Alright, so proceed tayo to problem number 3. For problem number 3, a stone was dropped from a balloon which is ascending at a rate of 6 meters per second when the balloon was 70 meters above the ground. Question number 1. What will be the velocity of the stone after 3 seconds? Question number 2. What will be the time required for the stone to attain a downward velocity of 15 meters per second? And number 3. How far the stone was from the ground after 4 seconds? And number 4. How long did it take the stone to hit the ground? So sabi ng problem, ang stone daw ay nilaglag, ang isang bato ay nilaglag mula sa hot air balloon na umaangat ng 6 meters per second. So yung bato ay nilaglag nung yung balloon ay nasa 70 meters above the ground. So question number 1. What will be the velocity of the stone after 3 seconds? So, given, ano ang given natin? Initial velocity, which is 6 meters per second. And then we have time na 3 seconds. And then the gravitational acceleration of 9.81 meter per square second. So we're looking for the velocity of the stone after 3 seconds. So looking back to our key formulas, ayan, makikita natin, unknown si V final, meron tayong V1, meron din tayong acceleration, meron tayong time. So we could use formula number 1, which is V is equals to V1 plus AT. So substituting all the formulas will result to V, or final velocity of the car after of the stone after 3 seconds, is equals to 23.43 meter per second. So never mind the negative sign, since it just indicates that the velocity is downward. Alright. Question number 2. What will be the time required for the stone to attain a downward velocity of 15 meters per second? Given, we have V1 is equals to 6 meters per second. V is equals to 15 meters per second. Gravitational acceleration is equals to 9.81 meter per square second. And the time which is unknown. So looking back ulit sa ating key formulas, meron tayong V1, meron tayong V, meron tayong A, unknown ay yung time. So we could use again formula number 1, which is V is equals to V1 plus AT. So substituting all the values, we have negative 15 meters per second equals 6 plus negative 9.81 times T. T is equals to 2.14 seconds. Okay po, so nilagyan natin na negative since the velocity is downward. Okay, question? Question number 3. How far the stone was from the ground after 4 seconds? So meron tayong given na V1 is equals to 6 meters per second, time which is 4 seconds, gravitational acceleration which is 9.81 meter per square second. We're looking for S. How far was the stone from the ground after 4 seconds? Ayan, since given naman yung V1, given yung time, given yung acceleration, therefore we could use formula number 3, which is S is equals to V1t plus 1/2 AT squared. Substituting all the values, S is equals to negative 54.48 meters or 54.48 meters below the point of release. So since the question is how far was the stone from the ground after 4 seconds. So from the ground, hindi yung tinatanong ay from the point of release. So ibig sabihin, kung nirelease yung bato ng 70 meters ang taas ng balloon, tapos after 4 seconds ay nasa 54.48 meters siya from point of release, therefore, ang bato from the ground ay is equals to 70 meters minus 54.48. S is equals to 15.52 meters from the ground. Ayan. So, medyo marami or halos lahat nagkamali dito. Kasi nga, iniisip nila na yung 54.48 ayun na mismo yung sagot. Which is hindi inanalyze yung question from the ground. Hindi sinabi na from the point of release. Ayan, next time, basahin mabuti, intindihin mabuti ang tanong bago magsulat ng final answer. Alright. Question number 4. How long did it take the stone to hit the ground? So, gaano katagal bago lumapat sa lupa yung bato na nilaglag? So, we have given V1 is equals to 6 meters per second. S is equals to 70 meters from the point of release. Gravitational acceleration, which is 9.81 meters per square second. We're looking for time. So, looking back sa ating formula, since given yung V1, given din yung S natin, unknown natin ay ang time, therefore, we could use again the formula number 3, which is S is equals to V1t plus 1/2 AT squared. Ayan. So, substituting the values in the formula, S is equals to V1t plus 1/2 AT squared. So, negative 7t is equals to 6t plus 1/2 times 9.81t squared. So reducing the formula will result to 0.4905t minus 60 minus 7t equals 0. So kung naalala nyo sa mathematics natin na subject, meron tayong quadratic formula to find the unknown, which is negative b plus minus the square root of b squared minus 4ac over 2a. Ayan po. So substituting all the values mula doon sa ating equation, sa ating quadratic equation, it will result to t is equals to 4.44 seconds. So whichever po na formula or na solution ang inyong gamitin, parehas po tayo ng sagot na 4.44 seconds. So wala pong problema kung anong solution yung ginamit nyo as long as parehas tayo ng final answer. Walang problema kung saan ka pang dumaan, basta nagkatagpo pa rin sa huli. Ayan. For problem number 4, a ball is thrown vertically upward with an initial velocity of 3 meters per second. From the top of the tall building, the ball strikes the ground 4 seconds later. Question number 1. What will be the highest point above the building reached by the ball? Number 2. How high is the building above the ground level? And number 3. How fast is the ball as it hits the ground? So, meron isang bola na inihagis mula sa taas ng building, inihagis pataas vertically upward. So, straight pataas hinagis ang bola. Sa initial velocity ay 3 meters per second. Then, after 4 seconds, yung bola ay bumagsak na sa lupa. So, question number 1, what will be the highest point above the building reached by the ball? So, sabi niya dito, ano daw ang highest point above the building reached by the ball? So, gaano kataas mula doon sa top ng building na ihagis yung bola or yung naabot ng bola nung hinagis siya? So, V1 is equals to 3 meters per second, gravitational acceleration which is 9.81 meter per square second. Meron tayong velocity final na 0 meter per second. Bakit? Kasi di ba pag isang bagay hinagis mo papunta sa taas, dadating yung point na mawawalan siya ng velocity. Pag naabot niya na yung highest peak niya, magsi-zero yung velocity, then saka siya babagsak pa ilalim. Kaya ang final velocity natin ay 0 meter per second. We're looking for S. Since given si V1, given si G or A, given din naman si V final, so we can use formula number 2, which is V squared is equals to V1 squared plus 2AS. Substituting all the formula, S1 is equals to 0.459 meters. So, ibig sabihin, ang naabot ng bola mula doon sa top ng building hanggang doon sa dulo na nag-zero yung velocity niya ay 0.459 meters. Question number 2. How high is the building above the ground level? So, meron tayong given na initial velocity is 3 meter per second, gravitational acceleration 9.81 meter per square second, and t is equals to 4 second S2. So kung makikita nyo sa figure, ang hinahanap natin is S2 or yung height ng building. So dito sa problem na to, sa question na to, meron tayong dalawang situation. Na kung saan, situation number 1 is the ball thrown upward. Nung hinagis natin yung bola pataas, syempre merong time na na-consume yun. Sa situation number 1, meron tayong separate given na initial velocity ay equal to 3 meters per second, then final velocity is equal to 0 meters per second, then G is equal to 9.81 meter per square second. So using formula number 1, V is equals to V1 plus 8T, 0 is equals to 3 plus 9.81 times T, T upward pa lang, itong arrow na to, T upward is equals to 0.31 seconds. Ngayon, so sinabi nung problem na after 4 seconds daw, simula nung tinapon yung bola pataas, after 4 seconds ay bumagsak na yung bola sa lupa or tumama na sa lupa yung bola. Ngayon for situation number 2, ball going downward. So kanina na-compute natin yung time na tinravel nung bola mula doon sa pagkahagis sa kanya hanggang doon sa highest point niya, which is 0.31 seconds. So ngayon, itong time na to, pagkahagis sa kanya nung bola pataas, nag-travel siya ng 0.31 seconds. Then, pagka dating niya sa pinakatuktok, syempre, bababa yun, malalaglag yung bola. Yung total na ng tinravel nung mula pagkahagis sa kanya hanggang siya ay makarating dun sa lupa ay 4 seconds. Pero nung sinolve natin kanina, yung upper, yung pagkahagis pa lang sa pataas, meron siyang time na 0.31 seconds. Therefore, ang time nung simula doon sa highest peak hanggang doon sa bumagsak sa lupa is equals to 4 seconds minus 0.31 seconds. So, time ng mula sa highest peak hanggang sa bumagsak yung bola doon sa lupa ay equal sa 3.69 seconds. Ayan. Since may given na tayo ng time, downward travel, so, isolve natin yung SD. Ito, yung na-travel na distance mula doon sa highest peak hanggang doon sa ground. So, given V1, given an acceleration, given yung time, so SD is equals to 66.79 meters. So, yung 66.79 meters, yun yung taas nung inabot nung bola hanggang doon sa pinakababa ng building. So ngayon, since ang question is height of the building, meron tayong height ng distance travel downward na 66.79. So mula dito sa highest peak hanggang doon sa pinakababa na 66.79. Then meron din tayong distance na yung travel kanina mula doon sa top ng building papunta doon sa highest peak, which are the S1, which is 0.459 meters. So kung titingnan natin yung figure, simple equation, height ng building or the S2 is equals to SD minus S1 will result to 66.331 meters. Ibig sabihin, yung building natin ay 66.331 meters. Question. Mahirap? Kayang-kaya yan. Problem number 4, question number 3. How fast is the ball as it hits the ground? So, gaano daw kabilis yung bola nung ito ay tumama sa lupa? Given, we have V1 mula doon sa highest peak. V1, syempre, doon sa highest peak, nag-start ulit siya sa 0. Kasi di ba nag-0 yung velocity niya kanina pagdating ng highest peak. Then, gravitational acceleration, which is 9.81 meter per square second. Time traveled downward, di ba nakumpute natin to kanina, which is 3.69 seconds. Then we have the distance traveled mula doon sa highest peak papunta doon sa baba na 66.79 meters. Ngayon ang tanong, ano daw ang velocity ng bola nung tumama siya sa lupa. So, given halos lahat ng values, syempre doon tayo sa pinakamadali. V is equals to V1 plus AT. Substituting all the values, 0 plus 9.81 times 3.69, V is equals to negative 36.20 meters. Ayan. So, yung bola ay tumama sa lupa ng may bilis na 36.20 meters per second. Again, take note, negative sign indicates that the velocity is downward. Ayan po, question. Alright. So, I hope guys, naintindihan nyo yung ating lesson. And I hope na nakuha nyo ng tama itong ating quiz and magiging reference nyo ito sa ating mga next exams at sa mga next exams pagid or next exams pa na may encounter nyo regarding rectilinear motion with constant acceleration. Alright? So that's all para doon sa ating solution para sa ating quiz 2 for rectilinear motion with constant acceleration. Alright? Thank you, class. And have a nice day.